Hi, good evening to all the audience. I, Rishan Alaki Jayasilan from BMMA S11 will present a video to you on our assignment poster presentation based on our lab 2, which is RDE Elemental Analysis, where together I and my fellow groupmates Gani Anak Liman, Amirul Fitri bin Jaafar, Muhammad Arif Shamim bin Mazlan, and Danasilan Anak Laki Devisilan from the same class as I am. I'll start off with the introduction to our topic, which will be the spectroscopy technique for detecting and qualifying elements in materials. Each element has a unique atomic structure used in lubricant analysis to detect worn metals, additive element levels, and contamination in oil. Fine particles generated by relative motion of metallic parts in an oil welted system. Lubricating oil acts as diagnostic medium carrying wear particles. Abnormal wear modes increase concentration of wear metals in oils. Contaminants detected and mix up or degraded lubricants identified by additive element concentrations. Multi-element analysis and knowledge of materials allow identifications of distressed components. The results are reported in ppm parts per million. Data indicates wear mechanisms and potential problems. Advanced warning allows corrective measures before serious damage or injury. The objective to our experiment is to analyze traced in lubricant sample to analyze signs of traced elements.
Hi, my name is Amirul Fitri. The first equipment is Spectral Oil 100 Analyzer. Spectral Oil 100 Analyzer is a real product developed by Spectral Scientific, a company specializing in fluid analysis and monitoring equipment. The Spectral Oil 100 is an elementalist analyzer specifically designed for oil analysis. It is used to determine the elemental composition and contamination level in lubricating oil and hydraulic fluids. It can detect and quantify elements such as wear metals, contaminants, additives, and other trace elements. Next, graphite rod. Before using the rod, it needs to be sharpened by using a special sharpener. Graphite rods are often used as the counter electrode in RDE setup. The counter electrode provides a pathway for the current to complete the electrochemical circuit during the analysis. Next, disc. The disc serves as a working electrode. The disc provides a defined surface area for electrochemical reaction to occur. Next is oil holder. It is to hold oil sample to put it inside the analyzer. And lastly, the sample oil. For this lab, we use sample oil B and sample oil B1.
Okay, my name is Gani Anak Liman and I will present about the methodology. Number one, setup and preparation. Ensure that you have a properly functioning RDE apparatus, including the rotating disc electrode, reference electrode, counter electrode, and working electrode. Prepare the electrolyte solution, which is dependent on the specific electrochemical system you are studying. Clean and polish the rotating disc electrode to remove any contaminants and ensure a clean surface for analysis. Number 2. Electro deposition. Immerse the rotating disc electrode in the electrolyte solution and establish the appropriate electrochemical core setup. Apply a potential or current to the working electrode to initiate the electrochemical reaction and deposit the desired element or compound on the electrode surface. Control the deposition time and conditions based on the specific experiment requirements. Number 3. Electrochemical analysis. After the electrode deposition, start the rotation of the disc electrode at a specific rotational speed to enhance mass transport and improve the accuracy of measurements. Apply a potential or current to the working electrode and record the resulting current response. Measure the current density as a function of potential or other relevant variables to study the electrochemical behavior of the deposited element. Number 4. Data interpretation. Analyze the recorded data considering parameters such as current density, potential, and rotational speed. Compare the obtained result with reference values or theoretical predictions to understand the electrochemical properties of the deposited element or compound.
Hi, I'm Arif and I will explain about the RDE elemental analysis results for the used oil and new oil samples that were obtained during our laboratory session. Specifically, sample B and sample B1 reveal significant differences in their elemental compositions. These results shed light on the presence and concentration of various elements within the sample. In terms of carbon concentration, the new oil sample B exhibit a higher level of 7,925 ppm compared to the used oil sample B1 with 7,514 ppm. This is expected as oil primarily consists of hydrocarbons, indicating that both samples are carbon rich. Aluminium is detected in both samples, but the concentration vary considerably. The new oil sample B shows a concentration of 0.32 ppm, while the used oil sample B1 has a significantly higher concentration of 10.93 ppm. The elevated level of aluminium in the used oil could suggest contamination from external sources or potential wear of aluminium-based components. Boron is present in both the new oil and used oil samples, with the used oil sample E1 demonstrating substantially higher concentration of 162.46 ppm compared to the new sample B with 30.29 ppm. This notable increase in boron content in the use of oil might indicate the depletion of boron containing additives or the ingress of external contaminants during usage. Barium concentrations also differ between the sample. The new oil sample B exhibits a concentration of 0.19 ppm, while the used oil sample B1 shows a slightly higher concentration of 1.04 ppm. The presence of barium in the used oil could be attributed to the presence of barium-based additive or the accumulation of wear debris. Calcium level display a significant difference between the two samples. The new oil sample B has a concentration of 58.24 ppm, whereas the used oil sample B1 display a substantially higher concentration of 313 and 14 ppm. The increases calcium content in the used oil suggests that the presence of calcium-based additive or the ingress of external contaminant during operation. Other elements including cadmium, chromium, copper, iron, potassium, lithium, magnesium, manganate, sodium, phosphorus, lead, silicon, and zinc also exhibit varying concentration between the used oil and new oil samples. The RDE elemental analysis result highlight the differences in elemental composition between the used oil and new oil sample. These variations can provide insights into the oil's condition, potential contamination, and the presence or depletion of specific additive. Further analysis and comparison with reference standard or previous analysis would be necessary to fully evaluate the oil's quality, assess its performance, and inform maintenance or replacement decision. Thank you.
Myself, Danasilan, another lucky day I'm going to explain the conclusion. From this lab session, knowledge about RDE element analysis has been acquired for two samples of oil, which is sample B and sample B1. Objective of the experiment are analyze the element trace in lubricant samples such as iron, natrium, and silicon, boron, and zinc. These elements help to improve lubricant characteristic, but at the same time become a poison to engine when it reaches its limit. By understanding this lab session, the element has been classified to three categories, which is wear, contaminant, and additive. These elements cause disadvantages to the vehicle engine such as clogging, wear, and sludge formation that can drop engine performance and damaging vehicle engine component part when it reaches its limit value. Thus, immediate action need to perform such as change engine oil and lubricant periodically to avoid the element reach its limit value. That's all for me. Thank you for everyone for the hard work and teamwork for completing this task. Thank you.